The temperature is negative 42 degrees Celsius in the deep bush of northern Ontario. You are standing on the front of a 20-ton iron platform, seated in a wooden chair that offers no protection from the elements. Behind you, a vertical boiler is screaming at 175 pounds per square inches, and 300 tons of white pine logs are chained to 8 sleds in a lethal articulated line. You feel the sleds lurch. The beast has hit an 8% downhill grade. On any other machine, you would reach for a brake lever. On a 1907 Lombard Steam Log Hauler, there are no brakes. Gravity has taken over. Your only tool is a heavy iron steering wheel that controls the massive front skis. If those skis catch an ice rut or the tracks behind you slip, the 320-ton mass will jackknife. You will be crushed between the boiler and the timber, or scalded to death as the steam pipes rupture. You don't jump, you stay, you steer. If you value these authentic historical films and the preservation of industrial heritage, please subscribe and like the video. Now, let's go back to the year 1901, where the impossible problem of the North met its mechanical match. The logging industry in Canada was, for decades, a hostage to the limitations of biological power. Horses were the engines of the forest, but a horse has a breaking point. On a level ice road, a team of 2 horses could pull perhaps 4 tons of timber. If the road thawed, they pulled nothing. If the road was too steep, the sled would override them, crushing the animals to death in a spray of splintered wood and bone. By the turn of the century, the timber near the rivers was gone. The lumber giants had to move deeper into the interior, into terrain that was too remote and too steep for horses. The industry was facing a total collapse of efficiency. They needed a machine that could move 50 times the load of a horse team, regardless of the mud or the incline. They needed something that didn't yet exist, a locomotive that carried its own road. Alvin Lombard, a blacksmith from Maine, looked at the problem and decided to abandon the wheel entirely. He looked at the laws of friction and surface area. He realized that if you distribute the weight over a continuous chain of iron plates, you could navigate the muskeg and the deep snow that would swallow a standard wheel. This was the birth of the first functional crawler track machine in history. Section 2. The Lombard Patent and Caterpillar's Genetic Ancestor. The anatomy of a Lombard steam log hauler is a study in brutal, asymmetrical engineering. At its heart sits a horizontal locomotive-style boiler, but the chassis beneath it is an architectural revolution. Traditional locomotives rely on the friction of steel on a prepared rail. The Lombard, however, carries its own rail." End quote. This is the first practical application of the continuous track. You are looking at 2 massive crawler assemblies at the rear, each featuring a heavy iron chain wrapped around a pair of sprockets. These tracks distribute the machine's 20-ton weight over a surface area of several thousand square inches. This results in a ground pressure lower than that of a human footprint. It is the only reason the machine doesn't sink into the frozen mud of Ontario. Technically, the Lombard is a masterpiece of saturated steam power. 2 vertical twin-cylinder engines are mounted on the front of the frame, driving a longitudinal shaft that powers the rear crawlers through a series of massive bevel gears. These engines are non-condensing. They exhaust their spent steam directly into the atmosphere through the smokestack to create a forced draft. This draft pulls air through the firebox, allowing the machine to burn green wood or low-grade coal in a furnace that reaches 1,200 degrees Celsius. Inside the boiler, the water undergoes a violent phase change. As it absorbs the latent heat of vaporization, it expands 1,600 times in volume. This expansion creates a pressure of 175 pounds per square inches against every square inch of the riveted steel plate. The most terrifying aspect of the Lombard's design is the steering mechanism. Unlike a train, which is guided by the track, or a truck, which uses a steering rack, the Lombard uses a pair of massive, hand-forged iron skis at the front. These skis are connected to a heavy iron wheel in the steersman's seat. There is no power steering. There is no hydraulic assist. You are fighting the physics of 20 tons of iron and 300 tons of wood using only the leverage of your own arms. If the skis hit a buried stump or a frozen ridge at 5 miles per hour, the kickback through the steering column can, and often does, break the steersman's wrists instantly. Furthermore, the machine lacks a differential. The two rear tracks are geared together. This means the Lombard wants to travel in a perfectly straight line. To turn, the steersman must force the skis to skid across the ice, fighting the immense traction of the crawlers behind him. It is a constant battle of mechanical willpower. You see the drive gears, exposed to the snow and grit, grinding against each other with a deafening metallic shriek. There are no shields. There are no safety guards." End quote. The technical precision of the 1900s was measured in the thickness of the iron and the endurance of the man who dared to steer it. Section 3. The suicide seat and the physics of sensation. The human toll of the Lombard is written in scars, lung tissue, and the silence of remote forest graves. To operate this machine was to exist in a state of sensory assault. You sit in the steersman's chair, located at the very front of the frame, completely exposed. Behind you is the radiant heat of a 1,200 degrees Celsius firebox. In front of you is a negative 40 degrees Celsius wind. This thermal gradient is a physiological nightmare. Your back is blistering while your face is frostbitten. The air you breathe is a toxic cocktail of coal smoke and fly ash, rich in carbon monoxide. This odorless gas binds to your hemoglobin 200 times more effectively than oxygen, leading to chronic headaches and a slow, cumulative fatigue that makes a 1-2 hour shift a struggle for consciousness. The mechanics of the machine create a constant threat of sudden trauma. The steersman is perched inches away from the heavy iron skis, while the fireman stands on a narrow, vibrating platform between the engine and the wood-filled tender. If the boiler experiences a crown sheet failure caused by the water level dropping too low over the firebox, the resulting explosion isn't just a fire, it is a physical displacement of reality. The energy released from 175 pounds per square inches steam is equivalent to several sticks of dynamite. The boiler becomes a rocket, and the crew is vaporized instantly. This wasn't a rare fear, it was a daily calculation. However, the most common killer was momentum. The Lombard hauled trains of up to 12 sleds. These sleds were connected by massive wooden poles called reaches and heavy chains. On a downhill run, if a chain snapped, the rear sleds would accelerate independently. This is known as a runaway. The wood doesn't stop. It piles up, a chaotic folding of 300 tons of timber that crushes the machine from behind. The steersman cannot jump to the side because of the deep snowbanks. He cannot jump forward because he would be run over by his own machine. He must stay at the wheel, fighting the 20-ton beast to stay on the road, praying the tracks don't slip. Beyond the immediate violence, there was the grind. Log haulers ran 24 hours a day in 2 shifts. You worked 12 hours in the dark, illuminated only by a dim oil lamp or the glow of the firebox. The vibration of the vertical cylinders causes a condition now known as hand-arm vibration syndrome, destroying the capillaries and nerves in the workers' hands. By the end of a winter season, many men could no longer fully close their fingers. They weren't victims. They were the elite. They were the only men with the technical instinct to feel a boiler's pressure through the soles of their boots and the nerve to steer 300 tons of death through a midnight blizzard. Section 4. The foundation of a global industrial titan. The transition from the violent, high-pressure roar of the haul to the rusted silence of the river landing marks the end of an era. You watch as the pin knockers move between the 8 sleds, pulling the heavy steel hitch pins that have held 300 tons of timber in a single lethal line. The Lombard, freed of its burden, seems to breathe a sigh of relief. its safety valves fluttering with a gentle hiss of escaping steam. By 1928, the steam-powered beast had run out of world to conquer. It was replaced not by a better log hauler, but by the bulldozer, a machine that could build year-round roads for trucks, rendering the specialized ice road physics of the Lombard obsolete. Technical precision in the 1930s meant moving toward the internal combustion engine. Gasoline and diesel were simpler. They didn't require a fireman to risk his life over a 175 psi-pressure vessel in the dark. You see the final Lombard, a diesel machine built in 1934, the same year the company closed its doors for good. Alvin Lombard died in 1937 at the age of 81, having watched the industry he helped build move past the very tool he invented. Most of the 83 steam machines ended as scrap or were simply abandoned beside logging roads in Ontario and Quebec, left to be reclaimed by the forest they once devoured. The human grit of the Lombard crews is an invisible monument built into the frames of the houses in Montreal, Toronto, and Boston. You realize that the impossible engineering of the log hauler was the labor that emancipated the horses, only to chain the men to a different kind of killing work. One specific archive-based fact from the American Society of Mechanical Engineers notes that in 1982, the Lombard was designated a National Historic Landmark. The plaque accurately states that it emancipated the horses. It doesn't mention the steersmen with the burn scars on their shoulders or the fingers lost to the iron wheel. As the fire in the box finally dies and the last of the steam dissipates into the crisp morning air, you feel a deep, reverent stillness. The era of the steam hauler was a brief, bloody chapter where our mechanical ambition outpaced our safety factors, but the legacy is immovable. The concept of the continuous track, proven in the freezing mud of the North, became the blueprint for the tanks of World War I and the machinery that builds our world today. We are left with the answer to our final question. Why did they climb back up? Because they were the men who could. They found a particular terrifying satisfaction in a run completed, a load delivered, and a machine still running at the end of it. They made a daily peace with risk because the alternative was a life that lacked the weight of responsibility and the thrill of the heavy haul. They don't make them like that anymore. Not the machines, and not the men.